Okay, let's dive into this explainer. Today, we're looking at a truly incredible artificial intelligence breakthrough it's making huge waves right now. We're talking about AI stepping up and actually solving an 80-year-old mathematical mystery. Specifically, we're going to look at how a system called FunSearch, which was developed by Google DeepMind, completely cracked a famously stubborn puzzle in pure mathematics known as the CAPSET problem. And look, this isn't just some neat parlor trick. It's a massive, massive leap forward in what machines can actually do for the scientific community. 80 years. Just think about that. For nearly a century, human experts, brilliant researchers, and top-tier mathematicians were left completely puzzled by this specific mathematical problem. To give you a quick idea of what they were up against without getting totally lost in the weeds here, the CAPSET problem is basically about finding the largest possible pattern of dots in a multidimensional grid where absolutely no three dots form a straight line. Right, so it sounds simple, kind of like a game of tic-tac-toe. But the catch is, as you add dimensions, the possibilities literally explode into numbers larger than the number of atoms in the observable universe. Generations of scholars spent their entire careers trying to map this out, pushing the very boundaries of human calculation, and they ultimately kept coming up short. And then, artificial intelligence cracked it wide open. It discovered new, record-breaking sizes for these CAPSETs that humans literally had never conceptualized before. Let's move to and see how this builds into Section 1, Beyond Text and Images, the Paradigm Shift in AI. And this brilliantly illustrates the shift we're seeing. We are so incredibly used to AI as this, generative novelty, a handy tool for writing emails, drafting marketing copy, or generating those fun, surreal pictures. That's the everyday utility we've all come to know, right? But we are now facing a brand new reality where AI is a problem-solving powerhouse, actively tackling hard science. To pull this off, the technology's underlying architecture had to fundamentally change. You see, standard language models, they're highly prone to hallucinations. They confidently make things up just to sound plausible. But obviously that doesn't work in pure mathematics, where an answer is strictly right or strictly wrong, no gray area. So, to bridge this gap and tackle these impossible challenges, researchers paired a creative language model with an automated evaluator. The AI generates millions of ideas in the form of computer code, and then the evaluator instantly tests them. It throws out the bad ones and feeds the good ones right back to the AI so it can improve. It totally removes the hallucinations and transforms the whole system into a rigorous scientific engine. Which brings us to Section 2, Accelerating Scientific Discovery, Tackling the Impossible. So the crucial point is that AI is no longer just assisting experts with busy work, it's actively accelerating scientific discovery by uncovering knowledge that we humans simply didn't possess before. And what's absolutely fascinating about this breakthrough isn't just that the AI found the right answer, it's exactly how it found it. Because the AI outputs its solutions as readable computer code, human mathematicians can actually analyze and understand the machine's underlying logic. Researchers noted that the AI didn't just act like some magic black box spitting out a correct number, it actually provided a completely new mathematical approach. So now, experts can study the AI's elegant code, learn from its novel strategy, and apply those fresh techniques to other unsolvable problems. It is the very definition of a scientific collaborator, helping us tackle the impossible together. Moving right along to Section 3, the future of science unfolding faster than ever. Now, what's really interesting about this slide is exactly what happens as this technology evolves. We're expecting a cascade of groundbreaking discoveries across mathematics, physics, medicine, and way beyond. It starts in math, sure, but it absolutely doesn't end there. Over in medicine, we're already seeing specialized systems used to predict highly complex 3D folding structures of proteins, which is drastically speeding up the development of new life-saving drugs. In physics and material science, AI models are currently sifting through millions of molecular combinations to discover entirely new materials for vastly more efficient batteries and sustainable solar panels. By applying this rigorous, evaluator-based AI approach, progress is accelerating across literally every major scientific discipline simultaneously. We're moving from a world where major scientific breakthroughs happen once a generation to one where they could happen continuously. As top researchers and technologists observing this massive shift have noted, the future of science is unfolding faster than ever, and that perfectly captures the sheer exhilarating piece of innovation we're witnessing in the scientific community right now. We aren't just walking into the future of discovery anymore. We are actively being propelled forward by a completely new methodology. This evolution of artificial intelligence is allowing experts to ask bigger questions and test hypotheses at a scale that was physically and mathematically impossible just a few short years ago. And finally, Section 4, humanity's greatest partner, solving the world's toughest problems. Which leads me to leave you with this final, really critical thought based on everything we've looked at today. Will AI become one of humanity's greatest partners in solving the world's toughest problems? I mean, from cracking 80-year-old math mysteries to designing the next generation of life-saving medicines, it's a truly fascinating and inspiring question to consider as we watch these incredible breakthroughs happen in real time. Thank you so much for joining me for this explainer, and I'm going to let you ponder that question until next time.